This is the product case study video for the ME110 Manufacturing Processes course. The product we're analyzing is the carbon monoxide alarm.
We begin our case study with the outer case of the carbon monoxide sensor. The casing was made by a process of injection molding. Injection molding is good at producing parts with complex shapes and good dimensional accuracy. There are several indications of this method, the most evident being the ejector pin marks. Other indications of injection molding include the gate. The gate is a small opening in which the melted plastic flows into the mold. Another indication are the parting lines. The parting line is where two halves of the mold meet. An alternative method to injection molding could have been casting. However, due to the complexity of the part and the high production rate, casting would have been more expensive than injection molding.
The next part of our product study case is analyzing the printed circuit board. On the lead side of the PCB board are small surface mounted components such as a microchip. On the insertion side of the PCB board are through-hole mounted components such as an LCD display panel or transistor. The multiple through-hole components suggest wave soldering was likely used. Also, the low thermal resistance of the through-hole components is another important indicator that wave soldering was used for these components, as they could not withstand the heat of a reflow oven. The surface-mounted components, on the other hand, are commonly attached to PCB boards by reflow soldering. If reflow soldering were used for the SMT components, however, then the wave soldering process would need to be applied last, so none of the through-hole components melt in the reflow oven. However, if the wave soldering were applied after the reflow soldering of the SMT components on the lead side of the board, then the SMT components would be soldered twice, which can cause defects, such as solder shorts. Thus, a method that was likely used was the SMT components were mounted with an adhesive on the lead side of the PCB board and then solidified. The board was flipped and the through-hole components were mounted on the certain side of the board. Then the lead side of the PCB board is wave soldered, allowing through-hole components and surface-mounted components to be attached with one process, saving manufacturing time and cost. Lastly, the carbon monoxide safety siren, which contains sulfuric acid to detect the carbon monoxide level, is most likely manually soldered on the lead side of the PCB board. The siren protrudes from both the lead side and the certain side of the PCB board, which would mean the siren would be destroyed if wave soldered on the lead side. Also, the solder connection between the siren and the PCB board was messy, which further suggests manual soldering. Alternatively, the siren could be wave soldered if it was initially only protruding from the certain side, then bent to its final position.
Our product features several sheet metal components incorporated both into the battery pack and upon the circuit board. Sheet metal rolling is a process through which the thickness of a workpiece is reduced in cross-sectional area. The process can be seen in the figure to the right. In the figure to the left, we can see a workpiece which we have assumed to have undergone lancing. Lancing is a process through which sheet metal is both sheared and bent in one stroke of a die, as you can see in this image here. In the figure to the right, we have assumed that this piece has undergone several bending processes. This piece here was likely stamped to get the shape of the indent that we can see.
Orientation and location of the board are defined by the inner walls of the casing and a pin. The board can only go into the case one way since the pin is off-centered and the inner walls of the case prevent rotation.